Hi everybody, we're going to talk about metallic bonding today. So metallic bonding occurs between atoms of the same metal. So if you have a piece of, let's say cobalt or a piece of sodium or something like that, the atoms within that metal bond metallically. And so let's write that down. So it occurs between atoms of the same metal. So if you take a metal and you look at its atoms, remember that metals prefer to lose electrons to become stable, like noble gases. And so metals tend to lose their electrons and become cations. So the first metal ion loses its electron, then the next one loses its electron, the next one does the same thing. So they all become metal cations so that they are stable. However, there's nowhere for these electrons to go, so they kind of like swim around, going from one to the other, but nobody really wants those electrons. So we say we have metal cations in a sea of delocalized electrons. So the metal cations are actually able to kind of like slide around each other because of that sea of electrons, and that causes many physical properties that we observe for metals that we don't see for something else. So for example, metals are really good conductors of both heat and electricity. And so the reason why they conduct electricity even as solids is because electricity is the flow of electrons. And so these electrons, because they are moving around already, are flowing. And so if you connect a wire with electricity, the electrons will just keep going. So you have metal conductivity that is because of that sea of electrons. See, luster is also because of the sea of electrons. It's called the photoelectric effect. Basically, when light shines on metals, we cause excitation of the electrons falling back down, emitting the light. So that's why metals are shiny. Also, malleability. And with that, ductility. So malleability means that when you bend them, they bend with you, they're not brittle. That's because the metal cations are able to move around because of the sea of electrons. They can slide past each other because of that sea of electrons, and so that causes metals to be malleable. Ductility means you can pull the metals into a wire. You can't do that with brittle things. So they kind of go hand in hand. So a lot of the metallic properties are because of that sea of electrons. Another one is that they have high melting points. That is also because of the sea of electrons, because there's a strong attraction between the positive cations and the negative electrons, and so that causes them to kind of stick together. They don't want to kind of melt or vaporize. They want to stay together, condensed as a solid. So lots of different properties caused by these sea of electrons. Really, any property of metals is because of that sea of electrons. It's a very unique type of bonding. The metals are arranged in a very compact and orderly crystalline pattern. Most metals have these repeating, very highly ordered units called crystals. And most solids form also crystals as well. Now we also have alloys. You're probably around you, there are more alloys than probably pure metals. What alloys are, they are physical mixtures of different metals together. So physical mixtures of two or more metals, usually made by melting the metals together. For example, remember in our penny lab we had brass, which was copper and zinc melted together, and it looked like a gold color. Steel is mostly iron with some carbon atoms, and then other metals depending on what they want that steel to have, what kind of properties they want that steel to have. So why do we make alloys? Well, the reason is alloys, based on what you melt together, can have different properties than the metal itself. So you can make alloys that are harder, that are stronger, that have a different melting point, that have a different type of malleability, that resist corrosion and rust. And so you can adjust the amounts of different metals to make it, whatever you want it to be. For example, gold is extremely malleable. I used to have a 21 karat gold bracelet when I was young, and 24 karat gold is pure gold, right? So 21 carats is a lot. Usually the gold that we buy is like 10, 14 karat. In European countries, usually they sell 18 karat, but 21 is still pretty malleable. And so what they do is they take that gold and they add silver and other metals to it to make it harder so it retains its shape. So when you make jewelry out of gold, you can have something that holds its shape. My bracelet that was 21 karat gold, when I would sleep with it, it would bend. You can literally bend it with your hand. So to make jewelry, you can't just use pure gold. You got to make an alloy. Steel. So iron is really good, but it rusts very easily. And so when they make steel that resists corrosion, like stainless steel, it resists corrosion and rust. So a lot of times we make these alloys to improve the properties of the metals that we are dealing with.